This is the 5-1 to 5-2 review. Number 3, calculators are still not allowed, so that means you're going to have to be able to graph these integrands without a calculator. All 3 of them involve absolute values, so you can either think of these as piecewise functions or you can think about v's that are being shifted around. If we look at this first one, we have an absolute value function that has been shifted to the left 2 units. So the graph of this would be a v with its vertex at -2 and side slopes of 1 and -1. And we're going to accumulate underneath that curve from -3 all the way up to +3. So in order to compute these areas, so that we can use the areas to figure out the integral, we're going to need to know the y-coordinates of the point so that we can get the dimensions of the shapes. So if I plug in a -3 into the function, I get a 1. And if I plug in a +3, I'm going to get a 5. So now I know the dimensions of the triangles will be 1 and 1 on this one, and 5 and 5 on the second one. So if I put those together, notice that the areas of both are above the x-axis, so the accumulation will be those areas added together. So I'll have 1/2 of 1 times 1 plus 1/2 of 5 times 5. That gives me 25 halves plus 1/2 is 26 halves, or 13. B is a little different because it's not just an absolute value, it's an absolute value that has been divided by a variable. So in order to work with this one, I'm going to rewrite that absolute value of x over x as a piecewise function because I don't know how to graph that without breaking it into its pieces. So we can see that that absolute value will leave the inside alone as long as the inside is positive, and it will take the opposite of the inside if the inside is negative. Well, that means we're going to get 1 whenever x is positive, and we'll get -1 whenever x is negative. So that means graphically, we have a +1 to the right of 0 and a -1 to the left of 0. And now I want to accumulate from -1 to +2. So remember, accumulations are y values, so you got to measure from the x-axis at all times, multiplied by delta x's. So if I compute this, I can see that I've got some area underneath that is a value of 1, and I've got some area up above that has a value of 2. So the integral will be the area above minus the area below. So I'll have a 2 minus a 1, or a 1. The third and final one in this problem is an absolute value that has been shifted around. So if we think about what happens, I take a basic v and I move it 2 to the right, and then I turn it upside down, and then I move it 2 up. So that means my picture will have a corner at 2, 2, and it will head down. So we'll go something like this. And if you can't remember how to do this, you can always just do a t-chart, and keep in mind that your t-chart needs values to the left and the right of the number that creates a 0 inside the integral. So now that I'm here, I need to accumulate from 1 to 3. So that would be from here to here. So we can see that we have a rectangle in here whose area is 2, and then we have a triangle whose base is 2 and whose height is 1. So the area of that would be 1. If I put them together, since they're both above the x-axis, I will get a value of 3 for the definite integral.